In this demo, we're going to take a look at how we can use the OCI Vision service to calculate the car park utilisation rate for our shopping mall. Let's have a quick look at some examples. So I can go ahead and drag and drop an image captured by our CCTV camera. And when I click on submit, what it will first do is send it off to the OCI Vision service, and it will calculate how many cars are present. So you can see it's gone ahead and calculated and highlighted for us the 4 cars present in the image. And based on that, it's gone ahead and calculated a utilisation rate of only 7%. Now, let's try that again with a slightly more busy image. So let's get something that was taken during the peak times. And it will do exactly the same thing. It will send this to the Vision service, and what it will do is detect all the different vehicles it can find. So as you can see, it's gone ahead and highlighted all the different cars it's detected, but also here you can see it's also detected a motorcycle as well. And because the car park's a lot more full, you can see the utilisation rate has increased to 85.45%. Now we can do this in batch, so I can go ahead and take all the images gathered within a 28-day period for every hour during our opening times, and get OCI Vision to calculate how the car park utilisation is changing over time. Now, the great thing is I can then visualise the outputs of OCI Vision within Oracle Analytics Cloud to allow me to interactively see how the trends are changing over time. So let's hop right into Oracle Analytics Cloud. So we can see a total of 414 images were taken in total, and from that, just under 12,000 different objects have been calculated. And those objects can be broken down into 5 distinct categories. And those 5 categories are land vehicles, trucks, vans, motorcycles, and cars. And I can hover over each one of these words in the tag cloud and see how many objects were captured. So as you can imagine, majority of them were cars at around 10,670. We can also see how the average car park utilisation rate is changing day in, day out. So you can see some obvious peaks at the weekends, and during the weekdays it quietened down a little bit. But we can also see how the average number of objects are changing hour in, hour out. So as you can imagine, it starts off quite slow, and then the number of objects detected starts increasing throughout the day and then starts tailing off during the evening. And the great thing is everything here is interactive, so I can go ahead and see all the different images, and I can go ahead and select on this specific image, which was taken at 10 o'clock, and we can see it's detected a motorcycle, 44 cars, and 2 land vehicles. And I can go ahead and hover over all the different objects detected, and we can also see a confidence rate. So it's detected a car, and it's 97% confident. Or in this case, it's detected a motorcycle and it's 96% confident. Now, let's take a look at how we can use the OCI speech and language AI services to process different complaints we've received for different stores. Let's have a quick look at how this works. So I can go ahead and drag and drop my audio file, and I'll just play you the first few seconds. Hello. I'd like to make a complaint about my recent visit to Elephant's Kitchen. I had to queue for a very long time. So once I go ahead and click on submit, what it will do is first send it to the speech service and provide me with a text transcription. That text transcription is then sent to the OCI language service, where it will extract key phrases, and also it will go ahead and detect aspects which have some sort of positive or negative sentiment associated with it. So let's go ahead and click on submit. So you can see at the top it's provided me with a text transcription of the audio file. So, for example, I had to queue for a very long time even though I made an online booking. It extracted key phrases. So recent visit, Elephant's Kitchen, waiter, marina, pizza. But also it detected aspects with some sort of negative or positive sentiment associated with it. So Elephant's Kitchen was negative, waiter was negative, order was negative, but the view out the restaurant was positive. And in total, what it's done is detected the total number of negative aspects. Now, we can also do this in batch. So I can take all the customer complaints gathered and pass them both to the OCI speech and language services to understand how the number of complaints are changing over time by different stores. Let's now jump into Oracle Analytics Cloud. So first we can go ahead and see how the number of complaints are changing week in, week out. And we can see where it's been increasing, where it's taken falls week in, week out. We can also slice and dice it by category of the store. So we can see on average, beauty stores have around 197 negatively sentimented aspects within their complaints. Down below, we can actually break this down into a distribution to see, what was the quartiles, the median, any outliers. So for example, if we look at banks and financial services, I can hover over and we can see the average number of negatively sentimented aspects was 195. However, if we come up here, there's this one bank in particular. So it had store ID number 2 and it received 491 negatively sentimented aspects in one single day. Now, this could be an outlier we might want to consider removing, or it just could be an example of where the bank had a few problems with their customers where they complained a lot. Also, we can then compare multiple malls with each other. So here, the darker the colour, the greater the number of negatively sentimented aspects were detected by each different category of store. So for example, within Mall B, there was a lot of issues with banks and financial services, whereas in Mall A, there wasn't as many. On the other hand, if we look at supermarkets, we can see Mall A has a much higher complaint ratio than Mall B. Let's now take a look at how we can do some of the data cleansing, feature engineering, and exploratory analysis stages of the data science lifecycle, still within Oracle Analytics Cloud. Before we start our exploratory analysis, let's have a look at the Oracle Analytics Cloud Dataset Editor. Here we can assess the quality of our data, make transformations, and also receive data enrichment recommendations from the machine. So here we can see a preview of our data, and at the top we can see a distribution of the values that are in each one of the columns. And for example, I could do some feature engineering, such as extracting certain date and time values from a date timestamp. So I can click on my date and I get some recommendations from the machine. So for example, if I want to go ahead and extract the year from the date, I can simply click on it. And what this will do is go ahead and create me a new column with the year extracted for me, as we can see. And I can scroll across and see the different distributions I have within my dataset. And I might come across examples where there'll be some data quality issues. So for example here, it's identified we have 5.29% missing values. Or for example, there may be some other quality issues such as we have 2 values for ground floor. So we've got ground floor here and we have ground level. So maybe we want to combine these into a single value. So I can double click on ground level and let's change this to ground floor. And I can click on enter. And maybe, for example, under store usage, I want to go ahead and change anything that's missing or null. And let's merge that into other, for example. So that will get rid of any of the blank or null values in the dataset. So here you saw we had 2 null values and you can see they've now been populated with other. And for example, I can go along and find all the different issues I have, make transformations, for example. And if I scroll across, we can see some of our other columns in the dataset, such as the average car park utilization, which we generated using OCI Vision, or calculating the number of negative aspects contained within complaints, which we generated using a combination of both speech and language services. Now, once we're happy with our changes, I can save the results and we can jump into my workbook to perform my exploratory analysis to get a better understanding of the data I'm working with. Now at the top of our dashboard, we can see some basic KPIs such as total number of malls, total number of stalls. We can also go ahead and see total revenue generated, also the total footfall for a 3-month period. We can start breaking down the footfall by mall. So we have 2 malls, Mall A in blue, and we can see how that's changing over time. We can see some peaks in the data, and also some troughs. And we can see down below for Mall B, it has a lot less total footfall compared to Mall A. Quite a cool feature, we can also use some natural language generation. So we can give it some data and get the machine to automatically generate and output for us a paragraph of text explaining what is going on. And the great thing is, once the underlying data changes, the text automatically regenerates itself as well. We can then start slicing and dicing the data to see how many stores we have by different categories, by location type, whether it's a shopping centre, whether it's freestanding, whether it's located outside. We can start having a look at the top 10 stores by daily revenue, or we can look at the top 10 stores by daily footfall. And once again, we can start comparing how the footfall breaks down by other attributes such as events. So we can see over time, the orange line represents footfall for when there was an event, and the blue line represents the footfall when there was no event being held. And we can see straight away, as soon as there's an event held, there's a big increase in the number of people visiting the stores. If I scroll down further, you can see there's loads of different ways we can slice the data, comparing footfall by total revenue. We can see if there's any trends between footfall and temperature. And if I scroll down below, we can start getting a bit more of a distribution to see the average footfall per store. So for example, what's quite interesting, if we look at the beauty department, the average store footfall was around 333 people. However, on this one day, they had 939 people, which is almost 3 times the amount of footfall. Now, is this an anomaly? Is this not an anomaly? Is this something we need to consider when building our footfall forecasting model? And then down below, we can also start doing some more advanced analytics, such as clustering stores by both store size versus footfall. So the further along the x-axis you go, the greater the store size, and higher up on the y-axis you go, the greater the footfall. And you can see our Oracle Analytics Cloud has automatically clustered the data into 5 clusters based on similar behavior in terms of how big their store is versus how much footfall they generate. So we can see cluster 4 here of about 5-6 different stores who have a very low store size but have a very high footfall. So maybe these are stores bringing in a lot of customers. Looking at the exact same data, we can do an outlier detection to see, right, what stores have a lot more footfall than the average. And you can see highlighted in red, it's got some extremities on the far right with very large stores, but also very small stores which have a larger footfall. And down below, we can also do some things like correlation matrices to see if there are any values that are highly correlated. So for example, here we can see total footfall and store size are highly correlated positively. However, if we look at number of COVID cases and revenue, or number of COVID cases and total footfall, you can see there's a slight negative correlation. And these are all things we want to consider before building our forecasting algorithm, looking at our highly correlated features, any outliers, possible clusters, distributions in our data. These are all important things which will anticipate how we go ahead and build our model. Now, let's say you don't know where to start and you want the machine to give you some recommendations. We have some cool features around Explain. So for example, I can go ahead and view my dataset, go down to Total Footfall, right click and click on Explain. And the machine will automatically use some AI and ML behind the scenes to explain to me what is going on with footfall. So first we get basic facts where it can go ahead and give us a distribution of our data. Now if I scroll down, it will start slicing and dicing the data by different attributes, whether that's date, weekdays. So, are there certain days where there's a lot more footfall, weekend, mall name, and so on. It will then segment our data for us. So here we can go ahead and see we had nearly 27,000 rows of data, and it's clustered it into 20 segments. And we can go ahead and scroll down to view those segments. 180 rows, or 0.7 of our data set. The data store category was beauty, and the average walking distance was between 288 and 306 meters. So if a new store came along, which was a beauty store, and the average walking distance was between these two values, they could expect a footfall of roughly 633, and so on and so on. And finally, it can also pick out any anomalies in your data. So the machine will look at some of your data, make a prediction, and if that prediction is far out from the actuals, it will flag that up as an anomaly, and it'll kind of give you a little description as well, explaining what possibly could, or where something could have gone wrong. Also, another quite cool feature, if you don't know where to start your analysis, we have something called Auto Insights. So if you click on the little light bulb at the top, it can automatically make some suggestions on your data set. So here, without me doing anything, the machine's automatically generated and outputted me some suggested visualizations I can start using, such as, pivot tables, line charts with some forecasts of temperature, histograms of temperature, histograms of average footfall values, and these are all useful charts that we could use in our exploratory analysis. Yet I've not generated any of them, and I can hover over it and it will automatically give me a text description or explaining what is going on with that visual. And if I'm interested, I can simply drag and drop it onto my page. Now, let's navigate into the OCI Data Science Service to see how we can train a forecasting model to predict footfall for each store for the next 14 days. We'll do this based on our footfall, car park utilisation and complaints data. Let's take a look at our notebook. The first thing I might want to do is go ahead and load in my dataset. So here we can see we have data for the footfall for each store every single day within our malls. And we can also say we've incorporated some other metrics that we've taken a look at earlier, such as the car park utilisation rate, the negative aspect complaints, but also we have that total footfall value we want to forecast. Now, if I scroll down a little bit, we can utilise some of the ADS capabilities to gain a statistical summary of our dataset. So in one single line of code, show in notebook, what I get is a nice UI giving me a summary of my data. So I can go ahead and see the number of rows, columns, data types. For each individual feature, I get a statistical summary showing me the number of unique values, counts, first, last value, means, medians, min-max values, and so on. If I scroll down furthermore, what we can start getting is a visualization for every single column in our dataset, showing a distribution of the values. So for example, if we go ahead and look at store size, for example, we can see the number of missing values. We can see the minimum value, the maximum value, and also a statistical summary looking at counts, frequency, and unique values. Now, I'm just going to close down this because we don't need to go through all of them. And next we can go ahead and look at our warnings. So here what it will do is look at our data set and flag up anything that might be a little bit suspicious that we need to take a look at before we start training our model. So for example, it's identified many columns which have missing values. It can identify high cardinality, correlations, if there's any zeros present in the data set. So it's giving us suggestions of where to look to do some data prep and cleansing. And if we scroll down, we can get a summary of some confusion matrices comparing continuous versus continuous columns, our categorical versus categorical columns, and also a combination of the two. So here we can start identifying columns that may be highly correlated to each other, indicating we might want to remove one or the other. If I scroll down, I can then kind of take the advice outputted from ADS and start making some data transformations, such as removing highly correlated features, fixing spelling mistakes found in some of the values, doing some filtering to remove stores that are still under construction. I can then also go ahead and start replacing any null values, maybe changing it to other, taking the mean value, filling it with a constant such as 0, 1, or 23. Now, once I've done that, I can then start looking at building my forecasting model. and to build my forecasting model, we'll be utilizing the Facebook profit algorithm, as it allows you to do multivariate forecasting. So not just forecasting based on footfall, but also taking into consideration other factors such as car park utilization and number of negative comments received. So if I scroll down, you can see what I've done is remove majority of the columns and just focused on some of the numerical metrics we have, such as for each store, we have each day the temperature, number of COVID cases, average car park utilization, number of complaints, revenue, and footfall. So what we'll do is use these first 5 attributes to forecast our footfall. Now, the first thing I can do is go ahead and split it into a training set and a test set. So what we'll do is go ahead and train our data on about 2.5 months worth of data, and then make a forecast for the next 14 days. And what I can do is compare my forecast with my test set to see how well it actually performed. And what we can do is go ahead and visualize that. So we can see the green line is representing my training data for 2.5 months. And then the purple line is showing me my test set, which I'll evaluate my model using. Now, what I can then go ahead and do for each store is generate its own forecast. So I'll iterate over all the stores in my dataset, train a Facebook profit forecasting algorithm, and then make a forecast for the next 14 days. And what we can do once that's done is start to visualize the outputs. Now, in total, it ran 279 different forecasts, each for a store. When it comes to visualizing, I can just focus on one store just for now. And we can see here the orange line is showing me the historical footfall for that store. We then have the green line in the middle, which is showing me the forecast. And just overlaid on this inside green line is a yellow line, which represents the actual values. And then at the top and bottom, you see a green line and a purple line, which represent the upper bound and lower bound respectively. And what we can do as well is to summarize the forecast and compare it to the actuals to generate some evaluation metrics and statistics. So one way we can do that is to visualize a residual plot, which compares the difference between the actuals and the forecast. And we can see for that 14-day period how that varies. So for example, in the first day, it was just under 10 off, whereas in the second day, it was 20 over. And for example, on the 5th day here, you can see it was out by about 40 people. So certain days it was very close to the actuals, whereas others, there was a bit of deviance from what was expected. Also, we can summarize it into 2 simple evaluation metrics. One is looking at the mean squared error, but also the mean absolute percentage error, which was only about 2.63%. So it performed fairly well. And then once we've done that and evaluated our model, we can then take the predictions for the next 14 days and head back into Oracle Analytics Cloud to visualize our results. Now, if we take a look at our outputs, the first thing to note is at the top, we have a filter bar where I'm just filtering on a single store to start off with. So here you can see we're only focusing on store 4, and below we can start visualizing the forecast outputs. So in this chart here, you can see the blue line, which represents the historical data, and then the green line represents the forecast that was made for the next 14 days. Now, you may be asking, what are the 2 red lines surrounding the forecast? And they're the upper bound and lower bound of that forecast. And if we drill slightly further, we can have a look at how the forecast actually compares to the actuals. So the purple line here is showing the actual results from the footfall for February, and the green line overlaid is our actual forecast. And what you can see is that overall it is quite accurate in predicting the footfall. So obviously some days it was a lot closer to others. So for example, on the 21st of February, the forecast was 595 people. However, the actuals was 622. Whereas some days, for example on the 25th, the forecast was 647, but the actuals was 654, so a lot closer. And we can go ahead and use the filters at the top to see how that changes for each store. Now, what we can also do is gain some bit more deeper business insights to start answering a few of our questions we had earlier. So for example, what were the top 10 stores with the highest forecasted footfall? So we can see here store 27 is estimated to have just over 13,000 people visit the store in the upcoming 2 weeks. We can also compare the footfall from the forecasted 2 weeks compared to the historical 2 weeks before this prediction was made. And we can see here within arts and attractions, we can see the footfall is about to change roughly 5,500 compared to 2 weeks prior. Whereas in department stores, there looks like there's going to be an increase of 1,600 people in the following 2 weeks compared to the prior 2 weeks before that. And finally, we can see fashion has a huge spike, where in the upcoming 2 weeks, it looks like there's going to be an increase of about 30,000 people. And what we can do is actually break that down by individual stores to look at the top 10 stores, which will have the greatest increase in footfall compared to 2 weeks ago. So we can see here store 154 is going to have an increase of 3,500. But on the complete opposite end, we can see store 334 is probably going to have a decline in footfall by about 2,800 in the upcoming 2 weeks. Drilling a little bit deeper, we can start looking at which stores would be overutilized and underutilized. So each dot here represents an individual store. The further along the x-axis you go, the bigger the store. And the further up the y-axis you go, the greater the number of footfall has been predicted. Now we can see majority of the stores lie within this trend, where bigger the store, the more likely they are to get a higher footfall. However, we can see there's a cluster in the top left-hand corner of relatively small stores, but they're expected to have a very, very high footfall. Whereas anything below this line, for example, we can see here store 193. Based on its store size, it looks like it's going to have a slightly less forecasted footfall compared to the average. And very similar, we can do the exact same thing, but this time, instead of looking at utilization, we can look at how well they're going to perform in terms of revenue. And once again, we can see stores above the line, which are looking like they're going to do better than expected, whereas things below the line are stores that are going to perform slightly less than expected. And finally, down at the bottom, we can start seeing how that compares to different metrics. So once again, in green, we have our forecast, and we can see how the trend compares with the average car park utilization rate. So it looks like, for example, when the average car park utilization rate looks like it's going to start to increase, the footfall is actually slightly taking a hit. And we can see that in the first forecasted week, but also in the second forecasted week. As soon as the utilization increases, the actual footfall to individual stores will start to decrease. And once again, we can look at how that compares to negative comments. So green representing the forecast and blue representing the negative complaints. And we can see here that there might be a slight correlation where the footfall is higher, the number of complaints is likely to be lower. Thank you for joining us on this end-to-end demo on how we use Composite AI to predict footfall for our stores for the next 14 days.